Well, hello everyone. We're taking a look today at Chapter 12, free response question number 1 from the Chapter 12 practice test. And the question goes like this. At Hogwarts, data was collected on the number of shots per game versus the number of goals scored for 10 random matches played by Ravenclaw's Quidditch team. A computer output for the regression analysis is provided below. So before we even get into anything, what I really want to do is just go ahead and pick apart this chart. So let's do that first. The first number in this chart is negative 24.534. That tells me that the y-intercept A is equal to negative 24.534. And that is the only number that we're going to use from this first line, the one that says constant over here. Everything else is irrelevant to AP Stats. On the second row, we have that 5.6 in the same row as shots per game. That number tells me that the slope of the regression line is 5.6. Next number in that same row is 2.158, and that is the standard error for B. So SEB equals 2.158. After that, we have T in the T column, 2.596. That is the test statistic. The test statistic is 2.596. The next number in that chart is 0.0318, and that number is the p-value, but it is a specific p-value. It's a p-value for a two-tailed test. So what this means is that 2 times the probability that T8 is greater than 2.158. 2 times the probability that T with 8 degrees of freedom is greater than 2.596. That's our test statistic. That's going to be equal to 0.0318. If you need the one-tailed test, you would divide that 0.0318. You would divide that by 2, and that would give you the test statistic for a one-tailed test. And that kind of completes that second row of our computer output. Scrolling down a little bit, we get to the very last line of this regressional output. And the first thing we see is S equals 9.366. That is the standard deviation of the residuals. So what that means is that a predicted value of number of goals varies from the actual number of goals by about 9.366 goals. If you think about that in context, that's a pretty big number, so I don't know how useful this particular regression is going to be. 9.3 goals per game seems like a lot. The next number is RSQ, and that is R squared. That tells me that R squared is equal to 0.457. The computer output always gives it to us in a percentage, but we're used to looking at that as a proportion or a decimal. Furthermore, since I already know that the value of B right over here is positive, that's a positive 5.6, we know that the value of R is going to be equal to the positive square root of 0.457, which is 0.676. Lastly, we get R squared adjusted, which is 38.9%. We don't actually use that number in AP Statistics, so you can just go ahead and put a line through it. All the other numbers we're going to be using, hopefully. Now let's just take a look at the graphs that we have here. I'll zoom in on them. This first graph that you see, that is the dot plot, and specifically it's a dot plot of shots in a game versus the number of goals. So we see that this This one right over here, that looks like about 11.5 shots per game. That's going to give us about 52, maybe 51 goals on average. Over here at the very end, we have about 17 shots per game. That's going to give us about 80 goals per game. So that it does look a little bit like a positive linear relationship. This one game right here, that kind of puts a little bit of a wrinkle in it, but no matter. We still see a positive linear regression. Well, maybe we can look at it a little more like this. Certainly this point right here is a bit influential. Now, if I take a look at the next plot here, this is the residuals. And the residuals definitely does not have strong skew. It does have a left skew a little bit, but that's not strong enough for us to say that it's strong left skew. Also, there are no outliers in the residual plot, so that's looking pretty good also. Again, this is a histogram of the residuals and not an actual residual plot. A residual plot would plot the x-coordinates against their corresponding residuals. And you can tell here because over on the dependent axis we have the word frequency. So it's a histogram. Next over here, this is the actual residual plot. Residual plot doesn't show a triangular pattern, so this looks pretty good for us as well. Let's go ahead and zoom out again, and we're going to use a computer output to discuss whether the conditions for a regression inference have been met. If you do not have enough information to check a condition, describe what further information would be required. Here are the conditions for a regressional inference. They are linear, linear scatter plot, independence, normal residuals, equal standard deviations, and random sample. So let's do the ones that are pretty easy for us. So first of all, the provided histogram of residuals did not have a strong skew or outliers. Again, that's this graph over here. No strong skew, no outliers. Our next condition is at equal standard deviation, and the provided residual plot does not show an increase or decrease in size. You can see this over here. All of the residuals are in this band over here. You can see as we read it from left to right or from right to left, we don't see an increase, nor do we see an increase, nor do we see a decrease. So that condition is satisfied. For the R random sample, we can quote from the problem, and the problem says very clearly that we are looking at 10 random matches played by Ravenclaw Quidditch. You can see that right over here. 10 random matches played by Ravenclaw Quidditch team. Next, we have L, and the provided scatter plot shows a roughly linear pattern, and the provided residual plot does not show a clear pattern as well. Here again is that residual plot, no clear pattern in the residual plot, and here again is that scatter plot. The scatter plot does show a roughly linear pattern. So we're clear on everything here except for the independent condition. And for this one, since this is a random sample, we just have to say that this is less than 10% of the number of matches played. And so for this one, we don't actually know how many matches Ravenclaw Quidditch is playing. So we're just going to assume that the 10 matches in our sample is less than 10% of the total number of matches played by Ravenclaw Quidditch. And that kind of takes care of all of letter A. So now we can go into letter B. And letter B, we're going to assume that the conditions for inference have met. I'm not going to mention them again because it does say that they are met. And there are two things to do. Both of these are inference procedures, and they both require a 4-step plan. It's kind of unlikely that on any single question you would do both a hypothesis test and a confidence interval. So this is a little bit of an unlikely question, but in the interest of doing a practice test, you probably would want to do both. So for letter B, we're going to state, plan, do, and conclude for evidence of a linear relationship. Now, evidence of a linear relationship basically means that we have to test whether or not B is not equal to 0. So state, first we're going to define our parameter, and our parameter in this case is beta. Beta is the true slope of the regression line relating shots and number of goals. For our hypotheses, we have beta is equal to 0 versus beta is not equal to 0. This is the correct set of hypotheses if we want to show that there is a linear relationship. Never mind whether or not that linear relationship is positive or negative. We just want to know if there is one. The last thing we'll need to do in our state part of the 4-step plan is to have a significance level. Since nothing is given to us, we're going to say that alpha is equal to 0.05. That does it for everything in state. Next, we're going to move on to plan. For the name of the procedure, this is a t-test for beta. For the conditions, the general formula, that's going to be the stat minus the null over the standard error. I think I'm going to zoom in a little bit here for you. Next is the specific formula. The test statistic is equal to, and that's B minus beta over SEB. Now for the work, we're going to go ahead and start substituting values in. And let's start substituting values here from what we figured out last time. B is 5.6. Beta equals 0. We can see that here from our hypothesis. And SEB, that's going to be 2.158. Now, all of that calculation here is a little bit for show because we already know if that part of the chart is open to us, we already know what the test statistic is. That test statistic is 2.596. So that the work that we're doing here, again, that's just for show, much like the way that our work was just for show when we were doing our chi-square procedures. Any case, the chart gave us the value of 2.596 for the test statistic. You don't even need to grab your calculator for that. The p-value, that's equal to, p-value equals 2 times the probability that the 8th degree of freedom on a t-curve is greater than 2.596, and that is 0.0318. We can read that directly from the chart because we are performing a two-tailed test. As a reminder, remember that if you are performing a one-tailed test, the p-value is going to be 0.0318 divided by 2. The last thing we're going to draw here is that normal-like curve. This is a t-curve with 8 degrees of freedom. And if our test statistic was 2.596, we're going to have to locate 2.596 and then carefully shade above that. But since we have a two-tailed test, we're also going to locate negative 2.596, and then we're going to shade below negative 2.596. So two-tailed test, you can tell because we have shaded the left tail and the right tail of this chart. There's that left tail, there's the right tail. Two-tailed test because we have a alternative hypothesis, which is beta not equal to. That leaves us with conclude. Since the p-value is less than 5%, we have convincing evidence for the alternative hypothesis. So we can conclude that a linear relationship between shots per game and goals scored exists for the Ravenclaw Quidditch team. So it exists, and that is just a re-summary of the alternative hypothesis. So that is part C, the hypothesis test, the provide convincing evidence of the linear relationship. And we're going to finish up now with part C, construct a 95% confidence interval for the slope of the population regression line for predicting goals from shots per game for Ravenclaw Quidditch. This is another state plan do conclude procedure. Remember, it's kind of rare for you, or it's very unlikely that you'll have to do both a confidence interval and a hypothesis test. This is just in the spirit of review for a test. Okay, so we'll start with state. The parameter beta is the true slope of the regression line relating shots and number of goals. Confidence level is 95%, and that's going to complete our state portion. Next, we have plan, the name of the procedure, and that is a confidence interval for beta. Just like last time, the conditions are going to be, we're going to assume that those conditions for inference have been satisfied. That's another quote from the problem, which brings us to the do. The general formula. We've got the point estimate plus or minus the margin of error. Specific formula B plus or minus T star SEB. Better make sure that multiplication sign is very well highlighted. The degree of freedom is n minus 2. Let's bring in that chart once again for the work. First number we're going to look for is B. B is 5.6. The next number from our chart is SEB. That's 2.158. We have 10 sets of coordinates, so our degree of freedom will be 10 minus 2. And then for our T star, we're going to have to go to our calculator and grab an inverse T. We want a 95% confidence interval, so 1 minus 0.95 divided by 2. And we have 10 pairs of coordinates, minus 2 for our degree of freedom. And that gives us a T star of 2.306. Let's bring in our calculator again, and we'll calculate our interval. Here we have 5.6 minus our, no, that's incorrect. Give me a second. That's better. 5.6 minus 2.306 multiplied by standard error of B, 2.158. And then the same thing, except for we're adding our margin of error instead. So for our answer, we will have 5.6 plus or minus 4.976. Conclusion time. So we are 95% confident that the interval from 0.62 to 10.58 goals per shot contains the true slope of the regression line relating goals to shots per game. So that concludes it here for our very first free response question. That was a lot to do, but you covered basically 2 or 3 different kinds of questions here. And we'll see you next time for free response question 2.